Good day everyone. Today I will teach you one Maxima Minima statement sum which is a bit different. It is based on a different concept. Okay, let us read the sum now. Find the dimensions of the rectangle of perimeter 36 cm which will sweep out a volume as large as possible when revolved about one of its sides. Also find its maximum volume. In this sum, there is a rectangle which is revolved about one of its axis. Now you should understand the concept. What will happen when a rectangle is revolved about one of its sides? First, let me tell you that, and then we will proceed with this maxima minima sum. Now see, this is a rectangle, okay? Now, this is L and this is B. Now, I can revolve this rectangle around either length or about breadth. Now see, now I hold this. This is my axis of rotation, this L, okay? Now I just rotate like this. I rotate, okay? When I rotate, what will happen? There will be a cylinder generated. When a rectangle is rotated through either a length or the breadth, you will be getting a cylinder, okay? Now, when this L is the axis of rotation, this L will become the height of the cylinder. This B will become the radius of the cylinder. Now, supposing on the other hand, let us keep it like this. Now, this B is the axis of rotation now. Okay, so let us hold that. We will rotate like this. So now again a cylinder is generated. Now what will happen? The B, that is the axis of rotation, that will become the height of the cylinder, and this L will become the radius of the cylinder. Okay, this is the main concept you should understand before proceeding to the maxima minima sum. So now I have just explained this using the figure. Now look at the figure. This is a rectangle. A, B, C, D is a rectangle. Here AB is the length L and BC is the breadth B. Okay, so length I am representing by the letter L and breadth I am representing by the letter B. Now I am taking, this is revolved about its breadth. We can take either breadth or length. Now I have taken, it is revolved about its breadth. That means the B is the axis of rotation. Okay, so whatever is the axis of rotation, that will become the height of the cylinder, I told you. Now this is the cylinder. Here this is the radius and this is the height. Now you see, B will become H, that is the axis of rotation, will become the height of the cylinder. And then the other one, that is the L, the other dimension, that will become the radius of the cylinder. Now as far as cylinder is concerned, you know the radius is R, height is H, and the volume we need, because the maximum volume is asked, the volume we are representing by the letter V. So now first we have drawn the figures. We have drawn a rectangle. Then we have drawn, when it is revolved about its breadth, there is a cylinder generated, and we have marked the H and R. Then what is the relation between this L, B, H and R? That we have arrived here. So B is H and L is R. So this is the preliminary thing. Unless you understand this, we won't be able to proceed to the sum at all. So hope this is clear to you. So as usual, first what will we do? We will draw the figure. We will be writing all the letters, whatever we represent. Then we will go to the given, then to prove all those things. So now the diagram is over. The letters we have already marked. So now let me go to the side heading given. Okay. Now read it. Find the dimensions of the rectangle of perimeter 36 centimeter. So what is given here? The perimeter is given. Okay. So the perimeter is equal to 36 centimeter. That is given. So the perimeter is constant. Not only it is just a constant, it is given 36 centimeter. So that we will be using. Then now here we have to find. Sometimes we will prove something, sometimes we will find something. Here two things we are going to find. One is you have to find the dimensions of the rectangle. The second one is find its maximum volume. Okay. So now find first one, the dimensions of the rectangle. This is what you are going to find. That is the L and B. Okay. So dimensions of the rectangle, that you will be finding. Then the second one is you will be finding the maximum volume. So that itself shows that you have to maximize the volume. This is maximum volume of the cylinder. Okay. So this is to find. So then comes the proof part. In the proof part, always take whatever is the constant. Whether you have a formula for that, you have to check and you have to write it. Now the constant, that is the perimeter. What is the formula for perimeter of the rectangle? P is equal to 2 into L plus B. That is given to be 36 now. So now your L plus B will be equal to 36 by 2, which will give you 18. Now you can either convert L in terms of B or B in terms of L. So let me write now. B is equal to 18 minus L. This is the conversion I am making from what is given. I can mark this as my step 1. Now what I have to maximize? I have to maximize the volume of the cylinder. So the volume of the cylinder, that we are representing by the letter V. Okay. So the volume of the cylinder V, you know the formula for the volume, pi r squared h. But now you know this pi you write as it is. You know that B becomes the L becomes the R here. So you write here L squared, and the B becomes the H. So you write B. Because our axis of rotation is B, that becomes the height, and then this L is R. Now we will be getting pi L squared B. Now you know B is equal to 18 minus L. So you write pi L squared into 18 minus L, which will give you pi into 18 L squared minus L cube. So now the V you are expressing in terms of only one variable L. That is the purpose. Usually whenever you get two variables, you convert one variable in terms of the other, and then the V which you are going to maximize, that should contain only one variable, that you have to remember. So now what you are getting now? V is equal to, you are having V is equal to pi into 18 L squared minus L cube. Now for V to be maximum, what are the two conditions? You know, for both maximum and minimum, the first derivative, that is dV by dL, should be equal to 0. Then if it is maximum, the second derivative, d square V by dL squared, should be lesser than 0. So these are the two conditions for you. So now let us find the two derivatives and then we will go to the conditions. So now your dV by dL will be, write the pi as it is. You will get here 36L minus 3L squared. The second derivative, d square V by dL squared is equal to pi into 36 minus 6L. So now the differentiation part is over. Equate the first derivative to 0. So the dV by dL is equal to pi into 36L minus 3L square, that is equal to 0. Pi cannot be 0. So 36L will be equal to 3L square. Cut that 3 and 36 12 times. 1 L will go. So you are getting L is equal to 12. You know L plus B is equal to 18. So L is 12. So B is 6. So you have got the dimensions of the rectangle now. So L is 12 centimeter and B is 6 centimeter. So one part is over. But we have to prove the second derivative is lesser than 0. So now come to the second derivative. That is d square V by dl squared is equal to, you know it is pi into 36 minus 6L. Now write d square V by dl square at L is equal to 12. You can write pi, you keep as it is, 36 minus 6 into 12 is 72. So 36 minus 72 is negation. You don't bother about the value, it is negation. So you can write it is lesser than 0. So you know if L is 12 and B is 6, then the volume is maximum you got. Now the question is, we have to find the maximum volume and we have to write the answers. Okay, so you know now what is L and what is B. So the volume, you got the formula pi into, okay, L square. Then you have got B. This is the thing. So now substitute pi into L is 12. So 12 squared. B is 6. So you will get pi into 144 into 6. That will be, you will be getting here 24, then 24, 26, 8. 864 pi cubic centimeters. Because centimeter is given, write cubic centimeter. If nothing is given, you can give cubic units. So here, now the conclusion is, okay, now let us write the conclusion. Two things we have found. One is the dimensions of the rectangle. First one is dimensions of the rectangle are L is equal to 12 centimeter, B is equal to 6 centimeter. This is one. The second one, the maximum volume. The maximum volume, actually it is of the cylinder only, that is 864 pi cubic centimeters. So, do you understand this sum? Here the concept is the main thing. If you understand, then the rest is actually easy. So, hope you have understood this. Subscribe to the channel and click the bell icon so that you will get notifications for further videos. Thanks for watching the video.